Dr. Lee Jinwoo stared at his computer screen in the quiet research lab. It was 3 a.m., and he was the only one still working at the Korean Space Research Institute. The numbers on his screen didn't make sense, but they kept appearing in the same pattern. He rubbed his tired eyes and checked the data again. The space telescope was sending back strange readings from a tiny black hole at the edge of our solar system. According to everything Jinwoo knew about physics, these readings should be impossible. Black holes were supposed to trap everything, even light. But this one was different. It seemed to be letting some information escape. Jinwoo reached for his phone and called his friend and colleague, Dr. Kim Ha-won. He knew she would still be awake. She often worked late too. Ha-won, I need you to look at something, he said as soon as she answered. The telescope data. It's showing something strange. Strange how? Ha-won asked. Jinwoo could hear her typing as she logged into the system remotely. Look at the quantum readings from the micro black hole we've been watching. See those patterns? They shouldn't exist. It's like the black hole is leaking. There was a long silence on the other end of the line. Jinwoo waited nervously. Ha-won was one of the best theoretical physicists in the country. If anyone could make sense of this, she could. This can't be right, she finally said. Run the tests again. Jinwoo had already run the tests 5 times, but he did it again anyway. The results were the same. The small black hole was definitely letting information escape, breaking one of the most basic rules of physics. I've never seen anything like this, Ha-won said. Her voice was excited now. If this data is correct, we might be looking at the answer to the black hole information paradox. This could change everything we know about physics. Jinwoo felt his heart beating faster. The black hole information paradox was one of the biggest mysteries in science. It asked a simple question. What happens to information when it falls into a black hole? According to quantum mechanics, information can't be destroyed. But according to Einstein's theories, anything that falls into a black hole is lost forever. Both ideas couldn't be true, but no one had been able to solve this puzzle. Until now. We need to tell Director Song, Jinwoo said. But first, let's make sure we haven't made any mistakes. They spent the next few hours checking and double-checking their work. As the sun rose over Seoul, they became more certain. They had discovered something revolutionary. At 9 a.m., they walked into Director Song's office. The director listened carefully as they explained what they had found. His expression changed from skeptical to amazed as they showed him the data. If you're right about this, Director Song said slowly, this discovery could be the biggest breakthrough in physics since Einstein. We need to set up a proper research team right away. As Jinwoo left the director's office, his phone buzzed. It was a message from Ha-won. We did it. Want to get coffee and plan our Nobel Prize speech. Jinwoo smiled, but he felt nervous too. He knew that big discoveries often came with big problems. As he walked back to his lab, he wondered what other secrets that small black hole might be hiding. He had a feeling this was just the beginning of something much bigger than a Nobel Prize. What he didn't know yet was just how right he was, and how this discovery would change not just physics, but the entire human race. 3 weeks had passed since Jinwoo and Ha-won's discovery. Their small lab at the Korean Space Research Institute had become the center of intense activity. Whiteboards covered with equations lined every wall, and empty coffee cups littered their desks. Look at this pattern again, Ha-won said, pointing to a graph on her computer screen. The information isn't just leaking randomly. It's like the black hole is encoding it somehow, storing it on its surface. Jinwoo nodded slowly. They had been working day and night, trying to understand what they were seeing. The more they studied the data, the stranger it became. The black hole wasn't destroying information as everyone had thought. Instead, it was transforming it. It's like a computer, Jinwoo said suddenly, sitting up straight. Not a normal computer, but something far more advanced. The event horizon. The edge of the black hole. It's acting like some kind of quantum hard drive. HFY's eyes widened. That's it. We need to write this up. Not just the observations, but a complete theory about how black holes handle information. They worked for hours, putting their ideas into words. Their paper explained how information might be preserved at the quantum level, encoded in tiny fluctuations at the edge of the black hole. It wasn't destroyed, just changed into a different form. As they finished the first draft, there was a knock at their lab door. Director Song entered, followed by a man they didn't recognize. Dr. Lee, Dr. Kim, Director Song said, "I'd like you to meet Dr. Park Do-hyun. He's one of our country's leading experts in quantum computing." Do-hyun stepped forward, his eyes bright with excitement. "I read your preliminary findings," he said. "I think you've discovered something even more important than you realize. If black holes really process information this way, we might be able to use similar principles to create an entirely new kind of quantum computer." Jin-woo and Ha-won exchanged surprised looks. They had been so focused on the physics that they hadn't thought much about practical applications. "How would that work?" Jin-woo asked. Do-hyun pulled up a chair and took out his tablet. "Look at these quantum computing models I've been working on. If we combine them with your theory about how black holes encode information, we might be able to create data storage systems more powerful than anything we've ever imagined." They spent the next few hours discussing possibilities. As they talked, Jin-woo noticed Ha-won growing quieter and quieter. "What's wrong?" he asked when they finally took a break. Ha-won looked worried. "If we're right about this, it changes everything we thought we knew about physics. But what if we're wrong? The whole scientific community will be watching us. If we make a mistake, then we'll learn from it," Do-hyun said firmly. "That's what science is about. And from what I've seen of your work, I don't think you're wrong." The next day, they submitted their paper to the top physics journal in the world. Within hours, their phones were ringing constantly. Scientists from every major research institution wanted to know more. As Jin-woo walked home that evening, he saw a shooting star streak across the sky. But now he wondered, how much information was hidden in that streak of light? How many secrets was the universe keeping, just waiting for humans to discover them? Little did he know that their theory was about to attract attention from much further away than Earth, and that their discovery was just the first step towards something far more extraordinary than any of them could imagine. 2 months after publishing their theory, Jin-woo stood in a large conference room at the International Space Center. Scientists and officials from 12 countries filled the room. Their discovery had sparked a global initiative to study the mysterious black hole up close. At the front of the room, Commander Choi Yoon-ah, one of Korea's most experienced astronauts, was explaining the mission plan. She pointed to a detailed hologram of a spacecraft. "This is the Quantum Explorer," she said, her voice clear and confident. "It will be the most advanced research vessel ever built. We've designed it specifically to study the quantum behavior of black holes." Jin-woo watched as the hologram rotated, showing the ship's complex sensor arrays. Beside him, Ha-won was taking detailed notes, while Do-hyun studied the quantum computing systems built into the ship's core. "The mission will take 6 months," Yuna continued. "We'll approach the black hole carefully, using the new quantum shields developed by our international team. Our primary goal is to collect data about how information behaves near the event horizon." After the presentation, Jin-woo, Ha-won, and Do-hyun met with Yuna in a smaller room. They would be the core research team on the mission. "I've read all your papers," Yuna said, "but I need to know if you're ready for this. Space is dangerous, and we'll be doing something no one has ever attempted before." "We understand the risks," Jin-woo said, "but this might be our only chance to solve one of the biggest mysteries in physics." Ha-won nodded. "Our calculations show the black hole is stable, but it's also unique. We've never seen one behave like this before." "That's what worries me," Do-hyun added. "My quantum computers are picking up patterns in the data that almost seem deliberate." Yuna raised an eyebrow. Deliberate? What do you mean? It's probably nothing, Do-hyun said quickly. Just an unusual quantum pattern. We'll know more when we get closer. The next few weeks passed in a blur of preparation. They trained in space simulators, learned emergency procedures, and studied every piece of data they had about the black hole. Finally, launch day arrived. Jinwoo stood in front of the massive quantum explorer, its silver hull gleaming in the morning sun. He thought about how far they had come since that late night in his lab. As they boarded the ship, Yuna turned to her crew. Remember, we're making history today. Whatever we find out there will change our understanding of the universe forever. The launch countdown began. Jinwoo felt the powerful engines rumble beneath him. As they lifted off, he looked out the window at Earth growing smaller below them. In his pocket was a small notebook where he had written his first observations about the strange black hole. Now they were heading to see it in person. What none of them knew was that their mission would reveal something far more extraordinary than they had imagined. The black hole wasn't just breaking the laws of physics. It was hiding a message that would change humanity's place in the universe. 3 months into their journey, the Quantum Explorer approached its destination. The tiny black hole appeared as a perfect dark circle against the stars, surrounded by a faint blue glow that shouldn't have been there. All sensors are active, Do-hyun reported from his station. The quantum computers were collecting data at an incredible rate. The patterns are getting stronger. They're unlike anything I've ever seen. Commander Yuna kept the ship at a safe distance. What are we looking at exactly? Jinwoo studied the readings on his screen. The quantum fluctuations at the event horizon. They're not random. There's a clear structure to them. Like a code. HFY asked, leaning forward to look at his display. More than that, Do-hyun said excitedly. The patterns repeat in specific sequences. It reminds me of how we store data in quantum computers, but far more advanced. Yuna frowned. Are you saying someone is using this black hole to store information? Before anyone could answer, the ship's sensors detected something new. The blue glow around the black hole pulsed in a regular rhythm. Look at this, HFY said, pointing to her screen. The quantum states are shifting. It's like the black hole is responding to our presence. Jinwoo felt a chill run down his spine. Their discovery was becoming something far stranger than they had imagined. Move us closer, he said to Yuna. We need better readings. The commander nodded and carefully guided the ship forward. As they approached, the quantum computers began picking up more detailed patterns. This is impossible, Do-hyun whispered, staring at his screen. These sequences, they're too perfect, too organized. Natural phenomena. Do-hyun's quantum computers worked through the night, decoding the patterns from the black hole. The crew took turns watching the data stream in, too excited to sleep. I think I've got something, Do-hyun said early the next morning. His hands shook slightly as he typed. The patterns are forming into readable data. The others gathered around his screen. Strings of numbers. Look at this again, Jinwoo said, pointing to the ancient message. We've been thinking about information all wrong. They had less than 2 hours left before the black hole's destabilization would become permanent. The red glow outside the ship had grown brighter, and the quantum readings were becoming more chaotic. What do you mean? HFY asked, moving closer to see his screen. We thought information was just stored at the event horizon, but it's not. It exists everywhere at once, in a quantum superposition throughout space-time. Jinwoo's eyes were bright with understanding. That's why our observations are causing problems. We're trying to measure it in just one place. Do-hyun's eyes widened. Of course, if we adjust our quantum computers to observe the entire field at once, we could stabilize it without getting too close to the event horizon. HFY finished, already starting new calculations. Commander Yuna watched them work. How sure are you about this? The ancient civilization's message showed us, Jinwoo explained. They didn't just store information in black holes, they used the entire fabric of space-time as one giant quantum computer. The black hole is just a focus point. Do-hyun's fingers flew over his keyboard as he reprogrammed the quantum computers. We'll need to use all our processing power. Every system on the ship will have to work together. Whatever we do, we need to do it fast, HFY said, checking the readings. The destabilization is accelerating. Yuna made her decision. Do it. They worked quickly, reconfiguring the ship's systems. The quantum computers hummed louder as they took on the massive task of observing quantum states across spacetime itself. Ready? Do-hyun said finally. Activating now. For a moment, nothing seemed to happen. Then the red glow around the black hole flickered. The warning alarms on the ship grew quieter. It's working, HFY whispered, watching the readings. The quantum state is stabilizing. The angry red glow faded, replaced by a soft purple light. The black hole's quantum patterns settled into a new, stable configuration. We did more than just stabilize it, Jinwoo said, studying the data. We've found a way to safely interact with it. This changes everything we thought we knew about quantum mechanics and information. As they watched, the purple glow pulsed gently, almost like a greeting. The ancient civilization's gift of knowledge was safe, and now humanity had learned how to use it properly. Send a message back to Earth, Yuna ordered. Tell them we're ready to begin the real research. And make sure they understand. This is just the beginning. 1 year after the Quantum Explorers mission, Jinwoo stood at a podium in Stockholm, accepting the Nobel Prize in Physics. HFY, Do-hyun, and Yuna sat in the front row, sharing in the triumph. The black hole information paradox taught us something important, Jinwoo said in his speech. Information is never truly lost. It just changes form, waiting for us to learn how to read it. Their discovery had changed the world. The first quantum black hole computer was already under construction in orbit around Earth. It would have more processing power than all traditional computers combined. Back in their lab in Korea, the team gathered to watch new data streaming in from the original black hole. The purple glow they had created still pulsed steadily, now serving as humanity's first library of quantum information. Remember when we thought we were just solving a physics problem? HFY asked, smiling as she worked on new equations. Do-hyun nodded, his quantum computers now 100 times more powerful thanks to what they had learned. And now we're building a network of quantum computers that use the fabric of spacetime itself. Commander Yuna, now director of the International Space Agency's Quantum Exploration Division, pulled up the latest construction plans. The second research ship launches next month. We've already found 3 more unusual black holes to study. Jinwoo looked at the images from space telescopes showing the strange purple glow around these distant black holes. They left them for us to find, he said quietly. The ancient civilization. They scattered these quantum libraries across the galaxy, waiting for someone to learn how to read them. The team had discovered that their black hole wasn't unique. It was part of a vast network, each one containing different pieces of knowledge. Humanity was taking its first steps toward becoming an advanced civilization themselves. New data coming in, Do-hyun announced. The screens filled with complex patterns that would have been meaningless a year ago. Now they could read them like a book. It's beautiful, HFY said, watching the quantum information flow. All this knowledge, preserved in the very structure of spacetime. Jinwoo picked up his old notebook, the one where he had first written down his observations about the strange black hole. On the last page, he wrote, "The greatest paradox wasn't about information at all. It was thinking we were alone in our quest for knowledge. The universe itself is one vast library, and we finally learned how to open the first book." Outside their window, the night sky sparkled with stars. Somewhere out there, more black holes waited with their stored knowledge, ready to help humanity take its next steps into the cosmic community.